Okay, so here, well, we're just doing another example. Okay. All right, so here, okay, we deposit again $23,000 into an account. We want the value of this 10 years later. Well, again, P0 is how much you deposit in the beginning, right? It's your initial amount. Okay. So that's what P0 is. That's $23,000. The APR, that's the percent you're given. So we convert that to a decimal, 7%, 0.07. 10 years later, right? That's our T is 10. So in each case, you're going to have something that looks like this. I mean, you got to figure out what N is. Notice I didn't tell you what N is. But in each case, you're going to have that. Except for D, though, actually. I should be a little bit careful. Now, why is D different? Because you have simple interest here. In other words, there's no compounding. So for part A, right? Part A, we have N is just 1, compounded once a year. So in that case, what happens? Well, we're going to have the amount, which is $23,000, right? It's compounded once, okay? It's going on for 10 years, once a year. $23,000 times all this, where N is 1, and we get this amount. Here, we have N is 12, okay? Okay, so that's 12. So we have $23,000, right? Again, that's our P0. 1 plus, in this case, N is 12. It's compounded monthly. So 0.07 over 12 raised to the 10 times 12. Again, we're just using our formula, and that gives us this. Good. Here, we have 365, daily. Plug it in. And we get this. Right? Again, P0 is always the same. That's our initial investment or the balance at the very beginning. R is the APR, in this case 7%, but you write it as a decimal, so it's 0.07. T is 10. How long this is going on for? Okay? Not only that, and again, N is what changes each time. So that's what we get. Now for simple interest, let's get the interest. So I is, again, P0 times R times T. So again, we're just using the formulas, right? We have $23,000 times 0.07 times 10, right? And we get this amount. Now this is just the interest, though. This better not to be the balance at the end because it's less than what we started with, right? But to get the actual balance, you could just add that to P0. And that's what we get. All right. So that's what we end up with here. Okay. Any questions on this? Okay. This one I was also going to have people try, but because of time, I think it'd be better if I do it with everyone. So let's just do that. Okay, so here we're calculating the APY for each of these three accounts, excuse me. And again, it's just that formula from before, right? If you can find it right here, okay? Right, we have 1 plus here we go. We have 1 plus R over N, right? Raised to the N minus 1. Again, we don't know the initial investment, but who cares? That doesn't matter. And what's nice is we don't need to know it. So in the first case, our R is 3.6%, but you convert it to, but you convert it to a decimal. Since we're compounded monthly, the account is compounded monthly, N is 12. Like so. So we have 1 plus this to the 12 minus 1. As you can see. And again, you know, if you do the calculation, this is what you get. But converting that to a percent, we get 3.66%. So this is the percent increase in the balance. For B, this is different. It's twice a year. It's compounded semi-annually. And again, that just means twice a year. So N in this case is 2. And R is also different. R is 5.8% as a decimal, meaning it's not a percent. So it's 0.058. So this is what we get. And we end up with this. And finally, for 4.7%, again, you convert that to a decimal, 0.047, that's our R. The N in this case is 365, so we get this, which is nice. So, you know, just some more examples to check out, that's all. All right, with that said, what I want to do now is start chapter 6. Okay, so I'm going to close this. Let me get to the next set of slides. Here we go. Chapter 6 is going to build on this. In that we're going to look at some other, well, you'll see what I mean, finance stuff. Here we go. Just going to be sharing it now. Okay. All right. All right, so here what we're going to see are special kinds of accounts, so to say, annuities, okay? First, we'll see what's called a savings annuity. I just called it an annuity. I think that's what the book does, and I wanted to be consistent. You know, we'll see what it is and all that. In particular, we'll also look at what's called a payout annuity. It's a little bit different. And then we'll see we'll look into loans. I mean, I know you're thinking we looked at loans a bit already. I mentioned it. Here we're going to get a little bit more general. In other words, we're going to be able to consider the case when you're making more than one deposit or withdrawal from the account. Not just with loans, but with these. So things will get a little more complicated, as you'll see. You know, it's not like going to be the case when we make just one deposit and we let the money sit there. We're not doing that. With loans, we're going to consider what happens also when you start repaying back the loan. You know, we'll see how much you owe and all that stuff. All right. So in particular, if we look at a savings annuity, and basically this is what happens in this kind of account, the idea is we're taking a little bit of money at a time, you know, from our paycheck every time we're paid, and we're putting it into a bank account. So we're making deposits at regular time intervals, you know, every month or once a year. This usually happens when someone has what's called a retirement account. You know, they're working and they want to build up, like they want to have money to live on when they're not able to work anymore and when they decide to retire. So what they do is they take a little money from each paycheck and they're putting it into a special kind of account. That account also is compounded as well. So not only is money going into the account at regular intervals, it's also being compounded. You know, in the previous chapter, we only considered when we made one deposit, but now we're going to be a little more realistic. And there are going to be assumptions we're going to have to make. For instance, we're assuming that we're going to put equal amounts of money into the account on a regular schedule. And we are going to let it sit there earning interest. In other words, what we're going to do is we're going to assume, like every month, we're taking a certain amount of money and we're putting it into the account regularly. So every month, we're putting a certain amount of money into that account. I mean, I know that's not too realistic because once in a while, someone could say, well, I got some extra money here. Let me put it into my retirement account. We're not going to assume, but we're going to keep it as, we're going to assume this though. And this is also going to come into play. We will assume as well the account is compounded as often as we make deposits. And that all compounding will occur at the end of the month. That's what we're going to assume throughout this chapter. Let me just see something. Yeah, okay. And that all compounding and payments occur at the end of the month. Okay, let me just cross that out. Okay. All right. Just to keep everything consistent. I know it's not too realistic, but again, just to set it up so that we can analyze it and see what's going on mathematically. These are the assumptions we're going to have to make. Okay, so again, I said this already a few times. Here, we're assuming that the account is compounded at the same frequency as we make deposits. And this is all going on at the end of the month. Okay, well, let me now illustrate what